Challenges in using biomass as a feedstock for bioenergy production. Biomass derived energy is considered to be more sustainable and eco friendly when compared to fossil fuel derived energy because the current bioenergy production mainly depends on terrestrial biomasses. This creates problems related to food security, land clearance, challenges in land use, water scarcity, etc. The first generation feedstock includes edible crops such as sugar, starch, grain, seed, and oil crops. Bioenergy production from this feedstock cannot satisfy the future demands since population is growing rapidly and thus first generation biomass alone cannot satisfy the need of growing population. Using edible crops for bioenergy production affect the global food security by creating food versus fuel dilemma. In other words, both bioenergy and food production compete for the same resources. Second generation feedstock includes non-edible biomasses such as lignocellulosic biomass, agriculture residue, industrial wood waste, etc. The major advantage of this feedstock is that it does not create any competition with food or feed. However, the major limitations of second generation feedstocks are a large amount of feedstock is required in order to meet the global demand for bioenergy and bioproducts. Thus, large area of land are required for the production of biomass, which will create shortage in the land for the cultivation of food crops and ultimately can affect the food security. Biomass production is a big problem in water scarce areas. Water security can also create competition between food crops and energy crops for the available source of water. Harsh conditions are required for the conversion of lignocellulosic biomass due to the presence of lignin. Algal biomass or third generation biomass feedstock is considered as an attractive feedstock for bio-based conversion processes nowadays. Both macroalgae and microalgae used for these purposes. The major reason for increasing the demand for algal biomass are algal biomass can overcome the limitation of both first generation and second generation feedstocks. Macroalgae can be grown in sea, whereas microalgae can be grown in open pond, photobioreactor, or even in wastewater. This will not create any competition for the available land or water resources for biomass production as seen in terrestrial feedstock. Microalgae can be grown in wastewater. This is an attractive way of biomass production since it offers wastewater management along with biomass production. It has a rapid growth rate. Its growth is 20 to 30 times quicker than terrestrial crops. Algae are rich source of protein, carbohydrate, unsaturated fatty acids, pigment, etc., which has applications in food, feed, chemical, cosmetics, pharmaceuticals, and biofuel industries. However, the major limitation associated with the algal biomass lies in the current technology to obtain algal components, which serve as the raw material for bio-based products. Cost-effective, mild, energy-efficient techniques are needed to be developed for isolation and conversion of algal-based components. Organic waste material is also an attractive feedstock for the production of bio-based products similar to algal biomass. The major advantages of using bio-waste is that it can be obtained in large amount and is also free of cost. Due to rapid urbanization, population growth, industrialization, huge amount of waste materials are produced every day. Proper management and recycling of this waste material is necessary. In order to minimize the risk on environment as well as on human health, utilizing organic waste for bioenergy production is an attractive way of bioremediation. Currently, there are various technologies for the conversion of waste to energy, including anaerobic digestion, fermentation, incineration, pyrolysis, gasification, etc. are available. However, heterogeneous variability in composition, high moisture content, and low calorific value of waste materials can affect the conversion process. Thus, the development of robust, large scale, and efficient processes are required for the proper conversion of waste to bioproducts at industrial scale.